All right, so this page continued on choosing the right kind of hypothesis test. A lot of kids would read this and think it's a 2 proportion because it looks like 85% is a proportion, and then you have H23 of 1,000 as in a proportion. This is actually just a single proportion test because you're comparing our one proportion to the claim. So your null hypothesis for this would be that the claim, 85%, is it significantly different from the pizza's industry's claim. You would test a not equal to 85. And then when you typed it in your calculator, that's when you'd put in the 823 out of 1,000. Okay, we're actually going to run a few tests together. So number 5 and 6, we're going to go through step by step. And number 10, 11, and 12, you can pause when I get to that part of the video and write the answers down if you want. So number 5 is 96.8 degrees, really normal body temperature. Some people studied it, and on 130 individuals, here's the mean and the standard deviation of the 130. So 98.25 degrees with a standard deviation of 0.73. Does this provide convincing evidence the body temperature is not 98.6 like we originally thought? So your null hypothesis is always that there is no change. You want to test that with the claim, 98.6. We're wondering if it's different, so we're going to do a not equals. And the type of test that we're going to use, so let's think of what kind of data we're given. We're given the mean and the standard deviation, and we're also given a sample size. We're given the sample standard deviation, so we're going to use a t-test. So it's been a while since we've used our calculator. Stat test, number 2. And do we have data or stats? We don't have our numbers in a list, so we're going to go to stats. This is the null hypothesis mean. We're going to test 98.6. Our sample mean is 98.25. Our standard deviation is 0.73. Our sample size is 130. And then this is where we would select if it's a not equals right here. And we're going to go to calculate. Your test statistic, if it's a t-test, is the t-value. So this negative 5.46. T equals negative 5.46. And our p-value, be careful, it's not 2.3. Look at this end, e negative 7. That means your p-value is 1, 2, 3, 4, 5, 6, 2, 2, 8. Really small. So our conclusion is that we're going to reject the null. So we're rejecting this statement. Sorry, that's an X. And we're accepting that it's different. So we're going to say the true mean temperature is significantly different. This is what we're accepting, than 98.6 degrees Fahrenheit. Okay, so take some time to process that and study that and know how to do this. Okay, this question. This is basically talking about how windy it is at 5 different locations. This is location 1, how windy it was in January compared with April. Location 2, January and April. So since these measurements come from the same weather station, that lets us know we want to have these pairs matched. Hint, on your exam, you're going to have one like this, but I'm already going to have a column right here that says differences, so that should help you a lot. So let's find the differences. I'm just going to subtract these, 139 minus 104. So we have 35, 11, or no, that's not right. That'd be 9. 126 minus 100, 26. Okay, now this one's going to be negative 18. No, negative 24. Good thing I typed in my calculator. And 78 minus 61 is 17. So these are the numbers we are going to enter in a list. If you forget how to go to a list, you do stat edit, and then I'm going to type in 35, 9, 26, negative 24, and 17. And we're going to run what's called a match pair t-test. So, let's talk about how to write the mean before we run that. Okay, so for a matched pair test, the average difference is 0, and we're interested if the wind gusts are higher in January. So, do you agree everywhere except this, the wind gusts were higher in January? The positive numbers represent what we're looking for, so we're going to test a greater than 0. So our null hypothesis is 0. This time I'm going to say it is from the data. It's from list 1. Leave your frequency 1. And then see how this is a greater than sign? You want to click on the one that's a greater than sign. And go to calculate. So there's our t value and our p value. I'm running out of room here. T equals 1.24. P equals 0.14. So that's not very small. So we're going to fail to reject the null. So we're going to write fail to reject the null. And we are going to say that this is not true. So wind in January is not significantly higher than April. Okay, and then you can read over what type of test I would use and study over questions 10, 11, and 12. Number 11 would be just called a z-test. 10, I have it spelled out there. You can type these in your calculator, and if you want to check these answers on Google Meet, we could do that. Number 11 is a z-test. Number 12 is a 2 proportion z-test. And here's how you'd write the hypothesis for that one. So if you want to just pause and write those down, I think that'd be a good idea.